Testing 1, 2, 3. Okay, so for informations for this video here, I would like to discuss on the set Percubaan for SEM1 maths question SM015 here. And maybe in this discussion here today, I won't talk so much on the concept on how to solve the question, but we just rather go directly on how to solve the questions with the steps only, not too much on the concept on how to solve the questions. Okay, so without further ado, let us go on with the very first questions here today. Regards on sections 8, question 1, which is dealing with chapter 8. Okay, so let's see. Have a quick look on what is the thing that we have overall in the questions here before we try to solve them one by one. Where according to these questions here, what we happens to see is that they ask us to evaluate the following limits. The evaluate words means that they want us the final answer in some real numbers. By right, you should have some real numbers, or you have some numbers answer for both of these. And then they want us to find the value of C based on these limits here, where this time the limit we already know the result of the limit value. So based on this limit value here, now we want to figure out what is the value of the C here. And let's see how we solve for these questions here. So we begin with question A1, where we want to evaluate these limits here. So for your informations, whenever you solve the limit questions, the first thing that should come in your mind, the first strategy that you should do is that we're trying to have direct substitute into the function. Regardless whether it's have modulus, if have quadratic factors, or is being factorized, you always begin with direct substitution. If possible to do direct substitution to get some real number answer, that will be the answer that we want for the result here. So in these calculations here, we find out that if we direct substitute -1 inside top and bottom, if I find out the top part, it doesn't give us any negative value. Oh, sorry, it doesn't give us the 0 is 0. It doesn't give us the result as 0. At the bottom also, it doesn't create anything like 0 or infinity. So I suppose this case here, I can solve by direct substitutions. So even though I have modulus, we just do direct substitution into the function. And the moment you substitute -1 inside, the limit notation will be gone as following. 5 multiply modulus -1 minus 4 times -1 power of 3 divide by -1 minus 2, 2 times -1 squared plus 1. And then simplify the answer. We find out on top we have 5 plus 4 after we simplify each of these terms here. Bottom, I have -3 multiplied 3. So as a result, this answer, when the time we further simplify, you find out that it's actually 9 over -9, where we have the answer equals to -1. That's it. Just direct substitution. 2 marks. Substitute, answer, 2 marks. Go on, part 2. Evaluate these limits here. So guys and girls, let's see. If I try again by direct substitution, and let's see what's the result that I'm supposed to have here. So I find out that the result I have here is that first, I have a constant minus 15 over 0. The other case, I have 15 over 0. And please, in these situations here, don't you just assume like 15 over 0 plus 15 over 0, so answer is 0 over 0, and then you do some sort of nonsense calculation. Or maybe some of you may claim that you get infinity plus infinity, so answer infinity. But instead, there is some strategies that we need to consider in order to solve for this type of questions. So how should we solve for these questions here is that if you're trying to figure out for the solution here, you will happen to find out in these calculations here, I can actually solve it by, instead of having two terms add up like this and create some indeterminate answer like what we have seen on top here. If you realize the denominator, we have the same functions, x plus 5. So by right, both of these fractions here, we can join them into one single fraction, where the idea is just like b over a plus c over a. the answer will just equals to B plus C over A because they have the same base number. So let us try to join them together. And as a result, what I have for my answer here is that I have the answer 3x plus 15 over x plus 5. And if this case, if I do direct substitution, I will have the answer of 0 over 0, as if like what we see just now, we have the answer of 0 over 0. But anyway, not proper to interpret 0 over 0 in this form here. But if I refer to this situation here, 0 over 0, so the strategy to solve is that we need to find out the factor that creating 0, then we cancel it. But it's the same factor top and bottom. So in this case here, if you try to factorize the top terms here, we factorize the 3. I will have it happens to be x plus 5 over x plus 5. And these two terms, it can be cancelled off, left with limits of constant 3. By the properties of limits, limit of a constant will just equal to the constant itself. So the answer is 3. So there goes the answer for A part 2. Next, B. We would like to find the value of C if let's say we have the case that limit at infinity, when x approaches to positive infinity, the value that we have for this limit is equal to a real number 1. And from there, we try to use this information to find out C. And let us try to have a look. If I direct substitute infinity inside for the function here, what will happen to be the result? Whenever you have the case of limit at infinity, we try to refer to the highest power of the terms that we have, and then we substitute it to decide whether I should get positive infinity, negative infinity, or whichever lah, which is appropriate. So in this case here, we notice that the highest power term we have two. One is x, the other one is square root of x squared. And both of these terms here is the highest power. And if let's say I substitute infinity inside for this x here, it's supposed to give me positive infinity. This one also, it will represent the whole thing, give me positive infinity also. So as a result, direct substitution will provide me the indeterminate form of infinity minus infinity. So infinity minus infinity, you cannot just come to the conclusion to say equal to 0, because we have no idea at this moment here whether these two infinity, are they equivalent big. So to avoid this indeterminate form for the calculation, what I need to do is that, so I try to avoid these situations here by multiply the conjugate of the square root here. So therefore, I will have limits x approaches to infinity. The functions, we multiply conjugate of these terms here, which is 3 plus square root over 3 plus square root, and then the result equals to 1. And be aware, why all of a sudden we can just multiply this thing here inside, and it doesn't affect any of my calculations result, is because the item here you multiply is equivalent to 1. You actually multiply 1 here. This one highlighted in yellow is actually 1. Whatever functions or number, when the time you multiply 1, the result is still maintains the same in terms of value. But of course, if you change the 1 in this form here, the value is maintained, but the form will be changed. And this is the objective we want to achieve. Maintain the value, change the form, so that we hope that the new form will help us to solve the questions. So in here, we multiply the top terms here, which is conjugate to each other. And in here, I need you to recall on this idea here in order to have a quick answer. If I have m minus n multiply with m plus n, the result will equals to m squared minus n squared. And in here, it's important to take notes. According to these two multiplication, the two terms that I try to highlight in blue now, when the time they multiply, you will find out that the 3x is the m, the square root term is the n. So as a result, we will have m squared, which is corresponding to 9x squared. Whereas the square root term, when the time you square it, just get rid of the square root lah. So what you happen to see is that this is m squared, n squared, and they minus each other. Denominator is maintained the same. The right hand side term also equal to 1, maintain the same. We copy back. Then we jump to here. Before we go on further, maybe some of you may question that how come we multiply conjugate in this case here? So maybe the strategy to think about the idea is that we can see in the way that, okay, maybe it's not a really appropriate way to do explanations, but think in this way here. You get infinity minus infinity, right? So how you get infinity is when the time you have a constant divided by 0 minus constant divided by 0. May not be the same constant, but in here we assume, again, like I say, it's not a very proper way to see that. But in here, as if like we assume in the wrong concept to say that I have constant minus this constant, so 0 over 0. Similar like the thing that we happen to explain on top lah. And this is the reason why it's dealing with the solution something like 0 over 0, we do cancellation of the factor creating 0. So now back to this thing here. So you're actually doing similar thing like here, and let us proceed the calculation so that we have a better idea. So 9x squared minus 9x squared minus cx, what I happen to have for my result here after I do this calculation is that I have limit approach to infinity cx over 3x plus square root of 9x squared minus cx equal to 1. And reach up to this moment here, if you try to do direct substitutions of the infinity inside, what you have for the situation is that you no longer see infinity minus infinity, but you meet another situation is that infinity over infinity. Another indeterminate situations, but these indeterminate situations, we can somehow solve it by divide with the highest power of denominator. So from this step here to the next step, how we get the answer for explanation, how I get the answer for this function part here. To have the answer later, I'm going to show. Let us focus on this part here that I try to highlight in purple, this part here. How it get the result at the bottom is that, okay, watch out. Whenever you have infinity or infinity, the idea now is doing is that we're going to divide 1 in the form of highest power of denominator. In here, the highest power of denominator, we have x and square root of x squared. So which are the one that we should choose? So maybe, again, focus on the part in purple first without the limit notation, because I just want to focus on this algorithm for the next part of the calculations. So focus on the functions here. What happens is that, okay, watch out carefully for the step-by-step calculations. I would like to divide 1 in the form of x over x. So as a result for the divisions, what you happen to find out is that for the top part that I highlighted in pink, you will find out that the result of the divisions would happen to be cx over x, which actually gives us the answer equivalent to c only. Then at the bottom part, each of the terms that I highlighted in yellow and blue, blue, I will divide with x as well. So what will happen when the time I divide with x is that you find out for the part in yellow, I can divide with x to become 3, but the part that highlighted in blue, I'm not able to divide it directly, but instead I will have hanging in this form here, a square root divided by x. And by the time I meet this situation here, square root divided by x, what I need to do is that I will try to simplify it in the way that I would like to convert this division terms here that I add in the x term here into some form that I can do division with the square root, where in here I need to consider the conversions of x into the form of square root of x squared. And for your informations, if I want to convert to square root of x squared, they might have two possible results, whether it's plus or minus. And I put question mark because which one should we take? So recall back on the relationship of modulus, the definition of modulus. We have two type definition. First one is that we have it as x and minus x for the case of x positive and x negative equal to 0. By right is either way will do. Either one of them put equal will do. But in here today the case is not valid to discuss equal to 0. So we doesn't have equal to 0. So this is first definition. Second definition, we have the case of square root of x squared. And based on this, you find out that square root of x squared, it will equals to x when the time we have x greater than 0. On the other hand, square root of x squared will equals to minus x when the time we have x less than 0. So in this case here, whether we are asking for the case of greater than 0, which is positive, or less than 0 for x, how you decide is that we refer to this part here. Your limits is x approach to positive infinity. So positive infinity, that means we are going to refer for greater than 0 case. So if greater than 0 case, that means that you find out that x is equal to square root of x squared. Therefore, this part here, you can actually return it as 3 plus square root of 9x squared minus cx divided by square root of x squared. And therefore, as a result, you will find out that this part of the calculations of the functions, we can simplify becomes c over 3 plus square root of 9x squared minus cx over x squared. And as a result now, it will turn into the function I have for the answer here. 9x squared divided by x squared, I got 9. Cx divided by x squared, I got c over x. So this is the result I have. And all this step here in red is just for explanation for you to understand how I get this calculation. You don't have to show this step here in red. Of course, if you want to show, you're welcome to, just that we don't want to waste time. If you understand the concept, we can just directly come to the result as I type here. And now, the moment we have done these divisions here, now you're supposed to can able to see if I have x approach to infinity, if I substitute into the position with x, which is only this bracket here, I have the case of constant over 0. When constant over 0, constant over infinity, not 0, constant over infinity, so the result will approximate to 0, no matter it's plus or minus infinity. So as a result, this whole function here, the next line, the limit notation will be gone, because if direct substitution infinity into here, I will have the c over x become 0. And this is the result I have. The c over x here, which is I try to highlight in purple. I try to highlight in purple. Will turn to become 0. The right hand side maintained as 1. Simplify our function. I find out that this is actually c over 6, where square root of 9 is 3. 3 plus 3 is 6. So c is equals to 6. There goes the answer for the c value. So this is how we get the answer for question number 1 in section A, which is related with the chapter 8, limit and continuity. And so far we're doing the limit situations only in here. Proceed. Next, we go for question 2 in section A. 9 marks is allocated, and this is the question dealing with chapter 9 on differentiations. And what is being tested here? Let's see. In these questions here, you are given the function fx is square root of x minus 4, where x is greater or equals to 4. They want us to show that fx plus h minus fx is actually equal to this function. Then they ask us to use first principle to find the derivative. And let's see how we get the first part to show first before we look at the first principle. So first of all, you need to be very clear. What is actually referred to fx plus h? Because fx is just this one, this is fx. What is fx plus h? So the idea is as if I refer to the function of fx. If all the x terms there, I convert into empty brackets. And what is the thing that I shall fill in for the empty bracket is that depends what you have in here. If here we have x, so it will be x also. If let's say here I fill in x plus h, so I will have x plus h in the brackets. So this is the thing that I need you to be clear. And of course, it's up to your creativity that whether you want to from here rewrite it in the form of x minus 4, then only plus h, also all right. Or you want to maintain as x plus h minus 4 is also all right. Whichever one is correct. But important thing is that you know the concept, how is the substitutions on fx plus h will do. So once you're clear about this thing here now, I would like to do this proving show here, start from the left hand side, and then try to obtain the result as the right hand side here. So now, continue. So fx plus h minus fx, it will actually equivalent to, I substitute h into the functions of fx, as I said just now. It's up to your choice whether you want to substitute from here, from the original framework, whether you want later convert to into here or this part here, whichever one will do lah. Depends which one is more convenient for your calculation. The important thing that the concept of the substitution of the h, you must be clear. And in my solution here, I begin with this form here, but without the brackets. So this is what I have. I substitute the x with x plus h, then minus fx. Go on. After I substitute this, it doesn't seem that this is the answer that I want to achieve, although even after I erase the brackets here, this is not the answer that I want to achieve according to the proving there. Where you see the proving there, I should have in the form of fractions, where I have the denominator of square root of x plus h minus 4 plus square root of x minus 4 at the denominator. But at this moment here, I doesn't have. But I can make it to have this form here where the whole thing of these terms here, you see, I do put the brackets there to consider the whole thing here multiplied with something. If you don't put this bracket here, it's as if like only the term square root of x minus 4 multiplied with the something behind it. That's why to make it very clear, to say that you multiply the whole thing here with the terms behind, I put the bracket there. And what we want to multiply with 1. Where in here, I want to emphasize 1 because why can we out of sudden multiply something, but the result is still valid? Because you are multiplying 1 before and after, the value is the same. However, multiply 1 in this form here is a bit meaningless, where not only the answer, the result is the same, but the form of the function will be the same. So what we want to do now is that I want the value is the same, but the form of the function make changes. And the one here, I will write it in terms of the conjugates of the square root terms. So once again, when the time you do multiplication on the top two terms here, you find out that you have x plus h minus 4 minus x minus 4. And how we get this result here, recall back, m minus n multiply m plus n equals to m square minus n square. So this is your m n plus minus. So the m square is just the m terms, get rid of square root. The n square, get rid of the square root, will be the n square. So this is how we get the answer. So this is the answer of m square minus n square. The bottom remain with these two square root terms. Reach up to here, we are almost there to get our answer if you realize. So you check, try to simplify the terms on top there. You find out that x minus x, we have a minus. And then also, we have -4 minus -4. So basically, those terms that I highlighted in green and red will be disappeared, left with h only on top. The bottom term is still the same. Therefore, this is the equation that we want to show in this calculation here. So we have done the proving. And before we go on further, it's important to take notes. When the time you do show, not only must have the value the same, but even the form of the function must be the same, which is they ask to show that we have x plus h. So x plus h, then only minus 4. So your arrangement also must be x plus h, then only minus 4. If you keep this part here to become like this, that is not proper lah. We must show until exactly the same as requirement of the questions. Go on. Once we're able to show this result here, now they ask us to use first principle to solve the questions. And how we solve by using first principle is that if you recall, if you want to find f prime by first principle, the formula will be limit h approach to 0 for fx plus h minus fx over h. Or sometimes we may write it in the form of 1 over h multiply fx plus h minus fx. Where the second form here is when the time, let's say the subtraction of the two function f is actually in the form of fractions. So we don't want to make it looks very complicated and bulky. So that's why we write in this second form also equivalent to the original formula. So we are going to apply this formula to find the derivative, which is the first principle. And if you realize these terms here that I highlighted in blue is what you have find out in your previous part in part A. This is the result. And even if you fail to get this result here from part A, you can just substitute this result here for further calculations. That's why they want to give the question of show, so that if let's say you don't know how to solve a certain part, you still can proceed further. So as a result, as you can see, if I refer to the first principle formula, if I refer to first principle formula in this form here behind here, so what happened in my calculation is that you will find out that I will have f prime equals to limits h over 1 over h multiplied with the term fx plus h minus fx. So this is the result that we have accordingly. And at this moment here, it's very obvious that I can simplify by cancel off the h. And if you realize in first principle, this is the objective that we want to do in order to get answer, where we find a way to cancel h top and bottom. You need not show me the cancellation sign, but you just need to show me the result of the cancellation, which is the following. After I cancel h, on top become 1. Then now at this moment here, all the h term, it should be safe to do direct substitution of 0. And here there is only one h term here. So we do direct substitutions. There goes the result. And if I happen to simplify this square root here, is actually 1 over square root of x minus 4 or plus square root of x minus 4. Two square root terms which is the same plus each other. So it will turn out the result as 2 times of the square root. And therefore this is the answer. Of course, if you don't believe this result here, you may try to do differentiations and try to see whether do you get this answer or not. And I suppose you will get this answer. So this is how we use first principle to get the answer for f prime. So I hope that you can remember the formula for first principle, or worst come to worst. Hopefully the formula is given and you're alert to notice and use it. Go on. Question number 3, which is the case about the applications of differentiations in section A, question 3. Marks given is 7 marks, allocated for 7 marks. And now, what is the question asked is that they want to find all the stationary point of fx equals to x power 4 minus 4x power 3 plus 15. So, how we get this answer here is that first of all, we need to know what is a stationary point. Of course, this point is defined in the function. The x is within the domain. And the stationary point is something related with the first derivative in here, which is the f prime. And how it related with the first derivative is that for stationary point, the first derivative will equals to 0. And therefore, with this clue here, in order to find the stationary point, which I want to find the x and y coordinates of the stationary point, I can make use of the conditions, the info, f prime equals to 0, to solve x, then follow solve y, and then form them in point form. Form them in coordinate form to answer the questions. So anyway, we need to find the first derivative first. So therefore, differentiate fx. I suppose my answer f prime equals to 4x power 3 minus 12x squared. Constant 15 differentiate will get 0, so we don't have to write the 0. Then next, take this function here equal to 0. So we have 4x power 3 minus 12x square equals to 0. And please, for this function here, although it's power of 3, you need not make use of calculator to do factorizations because it just only have x term. So you can just factorize the common factors from the constant and also from the x. In here, common factor on the constant will be 4. 4 and 12, common factor is 4. X power 3 and also x squared, the common factor is x squared. So we just factorize 4x squared out. So we have 4x squared multiplied x minus 3. Then this is equal to 0. From here, I suppose from 4x squared, you're able to get the x value is equal to 0. And at the same time, also, we have another possible x value where x equals to 3. And these two x value is the x coordinates of our stationary point. So for coordinate, I need x, I need y. So let us calculate the y value. And how we calculate the y value is that the y value is actually equals to the function value. So we substitute 0 and also 3 into the function on top. It will be the y answer. So we find out that for x equal to 0, y equals to f0. Substitute 0, I have answer 15. Similarly, for x equals to 3, the y is f3. Substitute, I have the answer equals to negative 12. Combine the x, y value together to form coordinates. I find out that the stationary point is 0, 15, 3 minus 12. And in here, suggestions to make your calculation more systematic and more organized. We arrange in ascending order according to the x coordinate. There is kecil sampai besar untuk the x coordinates. When the time you arrange the point, it will be much better. So there goes the 7 marks lah for these questions here. Okay. And please be aware that the question just asked for stationary point. So you don't have to go any further using a derivative test, whether first or second derivative test, to check which one is maximum, minimum, or inflection point. No need. The question just want to reach up to stationary point. So your answer is just reach until here. End of the story for question 3, section A. Next, we go for questions number 1 in section B. 5 marks is given, and these questions here related with chapter 1 for number system. And to be specific, in chapter 1, this is the case that we discuss on complex number. So if you are given a complex number according to the question, z equals to 2i over 1 minus I, the answer is to express z in the simplest Cartesian form. So what you mean by the simplest Cartesian form, which is I want the answer in the form of a plus bi, only a real number and also an imaginary number. And between them, it actually can have plus or minus, doesn't matter. Although in general, we like plus. But if the coefficient of I is minus, then it will be minus lah. A real minus imaginary. So important thing, must simplify until this form here. Then next, we want to find the exact value for the modulus of this z here. So to get the modulus of z, if this is the z, the complex number z, the modulus of z will equals to square root of the real parts square plus the imaginary part square. Just press calculator for answer. And let's see how we get the result here. So if you refer to the z, the complex number z, you find out that this is the case of irrational case where we have I at the denominator. Sorry, not to say the word irrational, but this is something that we need to rationalize it because we don't want to have I at the bottom in this case here. So in order to do the rationalization, what I need to do is that I need to multiply with something. And the something here, again, actually you are multiplying 1, but we don't write 1 in this form here because it's not only the value doesn't change, the form also doesn't change, so the problem forever unsolved. And why I want to mention 1 is because this is the reason why you can out of sudden multiply something to the terms there, but it doesn't change anything about the value. It still bring the same value in the discussion. And of course, the one here, we want to change some other form. And the form I want to change is that I want to change to 1 plus I, so that I can make the I at the bottom disappear by having the conjugate pair multiply each other. Then from there, we further proceed to simplify our answer. And you find out that multiply 1 plus I top and bottom, you will have the result as following: 2 multiply 1, 2I multiply 1, 2I multiply with I, we have 2I square behind, 2I in front, 2I, 2I square. Bottom, we have conjugate pair multiply each other, and the result is 1 plus 1. And how I get this result here is actually based on the shortcut where, observe, if let's say I have the scenario that I have A plus BI, sorry, let us according to the arrangement. Let's say start with A minus BI, multiply A plus BI. By using the rules of multiplications in algebra that we know, the properties that we know, the formula that we know, this multiplication will give us result m squared minus n squared. And by right, I will have a squared minus bi squared. And what is bi squared? Is actually b squared multiplied I squared. And you realize that I squared is actually equals to minus 1. So I have a squared minus b squared multiply minus 1, which is a squared plus b squared. So the a and b in this question here is 1 and also 1. So therefore, 1 square plus 1 square, there goes the result. Maybe this part here, to have a better reference, let me write it as 1 square plus 1 square. Or maybe if you don't like in this way here, you can also write it in the form of 1 square minus I square. Then we simplify our answer. You find out that the result is 2I minus 2 over 2. And where is this minus 2 come from? I squared is minus 1. So substitute minus 1. I have 2 multiply minus 1. So I have minus 2. Then divide with 2. It will give me the answer as following. Minus 1 plus I. And how I get this answer here? Watch out. I skip some step where initially each of these term, when the time you divide with 2, I will have I minus 1. But when the time you write the answer for Cartesian form, we always start with the real followed by imaginary. So that's why I put the negative 1 come first, then followed by I. So this is how I get my answer. Then without further ado, we find out the answer for the modulus of z. So again, how I get the answer for modulus of z is that where z is equals to a plus bi, so I will have modulus of z equals to square root of a squared plus b squared. In here, if you observe, a is minus 1, b is 1. So now we have square root of minus 1 square plus 1 square, answer square root of 2. So there goes the answer for the modulus according to the calculations here. And before we go on further, please recall back on how to find argument as well. Argument. Because argument is something very important to take notes, and a lot of students easily make mistake on the calculation of argument. And if you can get modulus and argument, then you should be able to get the answer for polar form. So make sure you don't put the terms wrongly in the polar form. Okay, so therefore question 1 we will stop at here because no more further question being asked. They just want the modulus. So don't please simply calculate the argument as well. In here, the remark here is asked to try to tell you study also these two things here, but it is not required in these questions. So this is a preparation. Maybe it come out in the exam later. Next, question number 2 in section B, 11 marks, related with chapter 2. Where chapter 2 we have equation, we have log indices third, we have equation on log indices third, then we have inequalities, we have absolute value. And let's see what we have in these questions here. Part A, they want us to solve these equations here where come with square root. The strategy to solve, as you know, is square both sides, but please square it correctly. Later we will explain further on how to solve this. Then B, find the interval of x which satisfies the following inequalities. So in here, they want to find the interval of x, so your final answer is in interval notation. Then watch out in these inequalities here. Some of you may happen to see that, there is two modulus there. So you think of got two modulus, then you do squaring both sides to get the answer. And in this case here, if you try to do squaring both sides to get the answer, then you are making yourself miserable, and it is nonsense to solve in the way like that. And how is the proper way to solve this question here? We will see in the solution later. Now we just have a quick view on the overall question and begin with question A now. Solve this square roots equations. So for these square root equations here, first we copy back the equations accordingly. Next, what I would like to do is that I would like to do squaring both sides. So guys and girls, be aware. When the time we say squaring both sides, right, the idea is like this. We will square in the way of the whole thing on left hand side we square equals to the whole thing on the right hand side is square. So this is the proper way that you should have, which is means that if let's say you have, for example, let's say I write some terms there. For example, I have 4 plus 1. I purposely use some figures, the fixed figures there, for you to observe the difference. And also, let's say I have the case of 7 minus 2. They are equal to each other, which is 5. Okay. When the time you want to square both sides, right, the correct way is that bracket like this, you square so that you still have 5 square equals to 5 square. But many students may have the misconception that when the time they do square both sides, which is this wrong concept here, they consider each of the terms you put square, which you have 4 square plus 1 square equals to 7 square minus 2 square. And obviously this calculation is wrong. You can try to check. 4 square is 16. 1 square is 1. 7 square is 49. 2 square is 4. So 17 versus 45. Do they happen to be still equal? Obviously, no. That's why this is not proper. So squaring both sides is the whole thing being square. Then proceed. When the time you have the square root function with two different square root, then what you need to do is that you must rearrange it so that each of the side have one square root, so that your expansion later will be much simpler in squaring both sides. So now I would like to square both sides on this equation here, and this is the result I have. The left hand side, square it, the square root is gone. The other one, square it, I have 1 minus square root of x bracket square. Be aware, yang ini salah. Sebab kalau you buat 1 minus x saja, that means you sedang buat konsep salah ini. Then now, the left hand side terms is still maintained the same. The right hand side terms, let us have a quick way to do the expansion. Recall on this formula here. M minus n, when the time you square it, you have the result equivalent to m square minus 2mn plus n square. And to have a much easier way for further calculation, maybe this arrangement here, we can arrange in the form of, I group the square term side by side, then minus 2mn. The reason why I want to do this arrangement in further calculation here is because you find out that this part here, the negative 2mn here, is the one that will remain square root later if you try to do expansions. So when the time we expand, this is the result lah. So this is the m square minus 2mn plus n square. So your m, the n. As you can see lah, the 2mn is happen to be come with the square root term. So maybe you can in early already group these two side by side. But of course, you don't want to group it side by side like what I'm having now is also all right. The next thing you need to do is that rearrange the equation so that square root on the left, the rest on the right. And as a result, when the time I rearrange the terms, I find out that the terms that I highlighted in yellow, I will rearrange to the left-hand side, whereas The full terms on the left hand side, I will rearrange to the right hand side. So I have the answer as the following. 2 square root of x equals to 6. When you find out that you rearrange the blue terms to the other side, you have x minus negative 5. So left with positive 6. Then reach up to here, you see that there is still square root there in your equation. Must say other square root in your equation. But now things change to much simpler, only one square root. And the next thing what you need to do is that make sure the arrangement is happen in the way that square root on one side, the rest on the other. Then you may proceed further for squaring both sides. And if you realize in my calculation here, I doesn't direct squaring both sides, but what I do is that I try to check before I square both sides, these two items here, do I have common factor? If there is, we try to reduce it, especially the constant that multiply the square root. We try to reduce it. It will make your calculation further much simpler. So now, from here, we divide with 2. So I have answer square root of 3 equals to, square root of x equals to 3. Then squaring both sides once again, I have the answer equals to 9. And therefore, this is the only result that we have. And I believe most of you, you see this final result here, somewhat is positive, and then you directly put hashtag, except this is the answer. But actually, you need to double check whether is this result a proper result. Adakah jawapan ini adalah jawapan betul atau jawapan yang merepek? Mungkin jawapan ini adalah jawapan yang merepek. Cuba kita check. Substitute this one to the left hand side and also to the right hand side. What you happen to find out is that if you try to do substitution, you have square root of 9 minus 5 on the left hand side. So you get square root of 4 to the other one. 1 minus square root of 9, 1 minus 3. Answer is equals to negative 2. By right, this answer we need to reject. Nampaknya ini soalan yang macam jahat sangat atau soalan yang rosak. By right, kita perlu reject. Sudah penat kira walau dia positif, we reject. And our answer is no solution. Tak ada solution. So please be aware on these questions here. And maybe this question kita perlu buat sikit pembetulan lah, di mana in order to make it have solutions, maybe I need to do something with this part here to do adjustment. Maybe I need to adjust it become who knows, square root of x minus 1. Maybe it will helps a bit to get the answer, I suppose. Okay. So just instantly in this moment here, let me try to make a corrections on these questions here, so that the solution we find out is more meaningful, where maybe the function now I want to change it to square root of x minus 5 equal to square root of x minus 1. Maybe we need to do corrections on these questions here. Then have a quick look on the calculation. Does it become more make sense if I try to do expansions? So I suppose I have here as x minus 2 square root of x plus 1. So rearrange, I will have the answer as 2 square root of x equals to 6 as well. Square root of x equals to 3. Square both sides, I have the answer as 9. So I still get the answer of, squaring both sides, I will have x equals to 9. And then let us try to have a quick check. When the time I have x equals to 9, so I have square root of 9 minus 4, answer is 2. The other side, square of 9 minus 1, so I have answer equals to 3 minus 1, 2. Okay, so I think this question here, I need to make a corrections. It's correction in the way that I should have it as square root of x minus 5 equals to square root of x minus 1. Buat pembetulan pada soalan ini. baru dia valid untuk teruskan kiraan. Kalau tidak, macam buat bodoh sajalah. The only solution you calculate out is the one that rejected lah. But anyway, who knows lah. The exam may happen to have some situation like this. You pernah solve, sebenarnya dia reject, no solution. Go on. So from here we can see like it's important the solution you obtain from square root equation mesti check balik. Mesti check balik guna calculator atau mind calculation. Because not every time the result generate out is relevant. Like this case here, dia tak relevant. Go on. Now, the next questions we have is that find the interval of x that satisfy the following inequalities. Okay, so let's see how we solve for this question here. So although there is two modulus there, we don't do squaring both sides. And if you try to observe carefully, when the time you do squaring both sides with the case of two modulus, the criteria you see is that the questions only have modulus term. All the terms is within the modulus. Dia tak ada term lain. In this case here, you realize there are the terms banyak di luar modulus. Like this. Yang multiply dengan modulus itu tak kisahlah. Tapi we have plus minus term outside of the modulus, then there is something not right there. Especially this term here cannot be simplified. Furthermore, another things that you happen to observe if you don't just memorize the step blindly, the two modulus that we have is actually the same modulus. Item yang sama. So kalau item yang sama sebenarnya we can reduce this item here. Kita boleh kurangkan item ini. So how we reduce it is that let us try to rearrange the two modulus that we have arranged to one side. Whether you want to keep them all on the left or on the right, it doesn't matter. But make sure if there is some number multiplied in front of the modulus, make sure that this number is a positive number before you go on for further calculations. And also make sure the modulus is on left hand side and with positive coefficient. What I mean by that, let's see. So now, the next line, what I do is that I rearrange the term where all the terms highlighted in blue, I rearrange to the right hand side and simplify them. So it turned out that it happens in the way that to get this answer is obtained from, let me explain in details. This is what's going on. I have 4 modulus 2 minus x minus modulus 2 minus x. So this item here is 4w minus w. So the result is 3w, which is 3 modulus 2 minus x. On the right, you will have the positive 6. Rearrange this one, minus x. Reach up to here, you see the coefficient of modulus is positive, but you don't define n or all at this moment here. You don't define into two cases because we want to have always the modulus term is on the left. I don't care it's followed by which inequality sign, but the modulus must be on the left and come with positive coefficient. Then only we start to do the definition using GOLA, LAGOLA, or whatever funny acronym terms that you remember. So now this thing here is actually equivalent to 3 modulus 2 minus x less than equal. Check the inequality sign. The pointing there, the pointing is pointing, the sharp part is pointing at the modulus term. And now it's time for us to define the modulus accordingly. And please be aware, it doesn't matter if you have a constant multiplier outside the modulus. Important is that it must be a positive number. If it's not a positive number, find a way to see can we adjust to make it positive number by rearrange, by multiplying, whichever that is relevant. So now we want to define the modulus. There is all sorts of different ways to define modulus, but I want you to observe the modulus terms here in this way here. As if like going to see in two packages. The package that I highlighted in purple and also the package that I highlighted in pink. Okay. So my definition, I will define in the way that after I have this formation, if I have less than, the relationship between the two cases I'm going to break later is come with the relationship of n. This word here is very, very important. Must be written. Then the first case and the second case, how we get the result is that, okay, for the purple part, what you always do is that you change the modulus bracket into round or square bracket depends on the situations. So therefore, you see the two definition case here. What I have is that you see the case that I highlighted in purple. You change the bracket, no more modulus there. Tukar bracket saja yang highlight purple. Yang highlight merah ini, I will tukar kepada dua warna. Satu warna merah, satu lagi warna kuning. Where warna merah is that maintain the same. Satu maintain. Satu, each of the terms we switch sign. So as a result, we have greater, equal, from less than become greater. Then the whole term here turn to come bracket minus. Of course, you may also switch one by one to get this form here. Switch sign, switch sign, switch sign. Positive become negative, negative become positive accordingly. Okay. Then now, after you have defined into two cases, watch out. This is case 1. This is case 2. Whenever you have case 1 and case 2, please alert in the way that you must from case 1 until solution 1, then only you look at case 2. You must solve all the way until we get solution of x for this case 1, then only you look for case 2. You don't do both of them at the same time to avoid unnecessary misunderstanding. So we find for solution 1, from here we expand, simplify. I find out that the x is greater than 0. So this is the answer for solution 1. Then only we start at case 2 to solve for solution 2. So again, we expand, simplify, I got solution 2. And after I get solution 1 and solution 2, what I want to do is that, how does these two solutions related? With the hinge of the word and, the solution I need to relate by intersect. So we try to draw both of these in the number line and look for their intersection. And please be aware, some of you get confused. How come sometimes the number line can't be plus minus? How come sometimes it's just reshape for intersect or union? So take notes. For the case that we just shade for intersect or union, of course, this is deal with the case that we want to see intersect of union or union from n and all of n or maybe all for the solution for case 1 and solution for case 2, like here. The case that we have plus minus for number line is when the time you try to solve some x value from an inequalities which is let's say greater than 0 or less than 0, that kind of thing. But now we are not doing the case that solve from some equation to see greater or less than 0. So therefore, the number line will be just referred to draw these two inequalities and find the intersection. So the diagram will be as follow. So the one in green is solution 1, solution 2 in diagram. And the shaded regions will be the final answer that we want, which is 0 to 3, and write in interval notation. If you're 0 to 3, close for both of them because include. And if you realize what is this thing here, is it compulsory to write? So usually in your answer, you will just write something like this. You tell that the interval is from 0 to 3. And what is this thing here is try to tell that the x is discussed that the variable that we want to find for this interval is x. The notation here is being read as element of. So in other words, when the time you write x followed by this notation here, we can as if like read in the form, understand in the form of x, the value of x is inside this interval. Okay. Of course, the final answer like this will be good enough lah for interval notation. Just that for you to take notes lah. Sometimes you may see we have it written in this way here with the x element of, which is more proper way. Go on. B, question number 3. Question number 3, this question here is regards on chapter 5. We have 7 marks allocated. And in these questions here, we have the question dealing with trigo functions. You're given tangent pi over 4 minus x, where 0, the domain is from 0 until pi, or I should not use the word domain here. where the condition for x is 0 until pi, because the condition of x is not necessary must be the domain of the function. It's just the conditions that we want to refer this part for the graph or for the functions. A, they want us to find asymptote. B, they want us to state the domain and range for fx and also sketch the graph. So how we get this answer here is that, let us see for the result. Go on. First, I would like to determine the asymptote of the function here, which is for tangent function. So watch out guys and girls, how you decide the answer for the asymptote for tangents. So please be aware in this idea here. Let's say like you have tangent, whatever function you have, let's say I put hashtag. Then for the case of asymptote, then you will find out that asymptote will always occur in the way that when the time you have hashtag equals to odd number multiplied with pi over 2. Or we say odd multiple of pi over 2. So this is the idea that how we get the answer is also written in this remark here, where we want the odd multiple of pi over 2. And by right, there's multiple of answer, but let us see the restrictions that we have in this interval here. So watch out. This is interval for x, but now the questions we have for the angle is not x, it's something else. So the something else as if like refer to the hashtag here. So I want to see within the interval for the case of pi over 4 minus x, what are the figures I need to consider? So by right, if I try to calculate out, I find out that this is the interval that I have. And within this interval, what are the odd multiple of pi over 2 I have is that if I realize the odd multiple, for example, I can multiply with negative value of minus 1. I can multiply with the value of positive 1. Multiply negative 1, I have negative 2 or negative pi over 2. The other one is pi over 2, and so on and so forth. But we start with these two first. If these two, if it's not included, then I shall not go on proceed further for the positive or negative side. So in here, negative pi over 2, we find out that it is happen to be within the interval. Yes, this is the answer that we want for further calculation. Pi over 2, we find out that it's not inside the interval because the highest I can go is pi over 4. So this one is out. So therefore, my calculation will equals in the way of taking the angle equals to negative pi over 2. Rearrange the equations. I suppose I have my answer, x equals to 3 pi over 4, where this is the location of our asymptote later. So the clue here important to take note is that the idea that I told you just now, this one, don't care lah what tangent, whatever angle inside. If you want to find asymptote, you take this angle here equal to the odd number multiple of pi over 2. And you check lah, within the given interval, from where to where is the answer. And the interval must regard on the interval of hashtag, not the x given in this form here. You need to come here x convert into the corresponding hashtag, like what I'm doing in this calculation here. Go on. So as a result, this is what we have for the answer. Okay, just in case you have no idea how can I from here convert into this form here. So let us slowly, everything in this term here, I multiply with negative 1. Inequality time, change directions. And then we write it in the form of less than. Then at last, we plus pi over 4 on both sides. So we have the result as pi over 4 minus pi. which gives us the result negative 3 pi over 4, 0 plus pi over 4, so I have pi over 4. So this is how I get the interval. Just a quick one. Next, I want to find the domain and range. So for information, the domain and range in this case here, how I get my answer is that, let us try to see. For the interval from 0 until pi, as required on the questions, how we get the domain and range is that first we start with the domain. We need to know for domain, for tangent, if you realize the tangent graph, it's always happen that we have some shape like this in general, asymptote, 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 so on and so forth. Basically, you can see that the graph in general for tangent, it can cover every single x value except the asymptote. And with the restriction of this interval here for the tangent, combined with the idea for the asymptote, it should be able to tell us that the restriction of the asymptote and also this interval here, it should be able to tell us that we have the interval happen in the way of, let's say, from 0 until pi. By right, I should exclude the asymptote 3 pi over 4. So your answer for the domain is supposed to be 0 to 3 pi over 4, union 3 pi over 4 until pi. Include 0 and pi because the question do have include. Then the range, as you can see the graph, I suppose in general you can see the graph can go from infinity to infinity. Of course, the better confirmation of the range here is that we try to see graph sketching. Who knows maybe the graph is stopped somewhere like this. Just have until highest at this point, lowest at this point. It doesn't go all the way to infinity. So we need to further verify with graph will be better. Go on. Next, for the graph sketchings, I need to know the informations accordingly like this. The function of the tangents, the interval, and also the vertical asymptote. So to sketch the graph, the further details on the techniques, the steps, you may refer to the video I have in my channel here. But anyway, today we just have a quick look on how to sketch this graph here. So step number 1 is that I want to find the phase shift, and how I get the phase shift is that I taking the angle here, make it equal to 0. So I take pi over 4 minus x equal to 0. The corresponding value for the x will be the phase shift, which is pi over 4. So what is the phase shift? The phase shift is that we try to investigate. If let's say I consider one cycle of the trigo, let's say the trigo shape is like this. The one cycle trigo shapes, the starting point, this point here, is located at where? I want to find this starting point here first. Next, I want to find the period, and how I get the period and what is the period. I want to know for this function here, one cycle like this, what is the length? And for the case of tangent, the period, we use the foundation of pi divided by modulus minus 1. What is this modulus minus 1? Is to actually refer to the coefficient of the x. So in other words, what actually happening is that we use tangent x as a reference. We notice that for tangent x, this one period here is actually pi. And if let's say I had the case of tangent mx plus c, then the period I will have pi divided by modulus m. Modulus is because your m may have negative sign like this case here. So coincidentally, the period is also 1. Then next, I want to go for subinterval. What is the use of the subinterval here is that they try to help us to determine some important point as reference, some important reference points for us to sketch the graph. Okay, so the subinterval, what I will have here is that I will consider, start from phase shift. The next value I want to refer will be what is based on, you take the period divided by 4. So I will have pi over 4. So when the time you construct the table for further calculation, the xy will be, so I will have for the x, start with the phase shift, calculate the y value, substitute into the function, I got 0. The next value I will plus this subinterval value pi over 4, plus this one inside. So I have pi over 2. The corresponding y is -1. Continue. Again, plus pi over 4, I find out that I have 3 pi over 4, which is actually the vertical asymptote. So in the calculator, you find out that it's something right now like error in this part here, because it's a vertical asymptote, it's undefined here. Proceed further for the rest of the x value and the corresponding y. So now I got this answer here. And what is this answer trying to tell us is that just have a rough sketching. By right, I have pi over 4, pi over 2, 3 pi over 4, and also pi, 5 pi over 4. And by right, this one is the asymptote. And by the time I sketch the graph, it will happens to look in the way that start with 0, -1. So my graph by right, it will curve like this, curving down. This value here is a reference for us to know from 0 to the asymptote is going up or going down. Then pi at 1, 5 pi over 4 at 0. So we know that the curve is like this. So therefore, I know the shape of the graph will look something like this. And then in your drawing, the important point that you need to show in the diagram is just this 3 part I highlight. So now with this info here, what I do is that I try to sketch the one cycle graph where I will have it looks something like this: pi over 4, 3 pi over 4, followed by 5 pi over 4. Asymptote. This is the shape of the graph that I have for one cycle. One cycle is this. And watch out. This is not yet the final answer. Not because you haven't put the y-axis inside, because this interval here for one cycle does not fulfill the question. The question asks for 0 until pi. So this is not 0 until pi. So I need to make some adjustment in the way that where is 0? Maybe somewhere here. Maybe somewhere here, 0. Then pi, maybe somewhere here. So I need to cut off this extra part here that I highlighted in red. Then extend the graph all the way, reach until 0 to complete the diagram. And at this point of 0 and pi, do I have include the corresponding y value of these two or not? I need to consider, do I have equal sign for 0 and pi or not? In this case here, if yes, then I need to leave my diagrams come with shaded dots. Then I connect them. Shaded dots. Then I cut off this part here. And therefore, the result is as shown in the diagram here. So this is what I have for my diagram. As you can see in this part here, that I do the extensions. Then the other side, this part here, I cut off the unnecessary point which is outside of the domain. So this is the answer we want for the questions. And as you can see, there's a x-intercept and y-intercept. So make sure you have the labeling of the value of them. Then next we go on with question number 4 in section B. This question here is involved of chapter 5, function and graph. Marks given is 14 marks. And you're given exponential functions. They ask us to find domain and range. Show that it's a one-to-one function using algebraic methods. Find inverse, domain and range for inverse. I think that is a wrong spelling here. The range, the E is missing. Then using the result in B, this result, I think it's not result in B. I think it's a typing error. It's supposed to be result in D. Sorry, result in not B. Result of the inverse function. I think there is a typing error there. It should be result of the F inverse. We find this answer here. Sorry for the mistake here in the questions. So after we have identified the corrections, so let me again check back. This one is supposed to be from part C, right? By using the result in part C. The part C, which is the inverse, not B, not the one-to-one. The one-to-one won't be helped in solving the question. Okay, so now let us tackle one by one. First, find the domain and range for F. So in this question here, I think domain, just use common sense to see what are the x value that is undefined in this case here. What are the x value when the time you substitute inside, it will happen to make the function undefined. You find out that no value substitute inside will make the function undefined. Therefore, the domain is infinity to infinity. You boleh belasah apa-apa x value substitute masuk saja. So domain infinity to infinity. Range. So use our common sense. You notice that this one here is always positive. A positive number plus C4, it will give us the result of the function value or the range. It is always 4. This is always greater than 4. 4 plus always greater than 4. Not include 4 in here. Because this term here can never ever be 0. That goes the domain and range. Then by algebraic methods, show that fx is a one-to-one function. So what is algebraic methods here is that we're trying to consider, in here I use the word let to replace the word consider. If I have fx1 equals to fx2, where this statement here, the let is that we try to suspect in the way that if it was told that fx1 give the same y value, sorry, or I should say x1 give the same y value as x2, in the end of our calculation, do we find out that x1 and x2, are they actually refer to the same point? If yes, one-to-one. If no, not one-to-one. This is what we're trying to investigate in the calculations. And of course, the x1 and x2 must be inside the domain. So in here, we let fx1 equals to fx2. Substitute x1 and x2 into the function. Simplify the constant plus 4 on both sides, where we minus 4 on both sides. We let with the exponent 5 power of 3 minus x1, 5 power x, 3 minus x2. Then next, what I would like to do is that, okay, I would like to insert log to the base 5 on both sides. So I find the power of 3 minus x1. Find the power of 3 minus x1 by the properties of log. It should give me the answer just equal to the power 3 minus x1, 3 minus x2. From there we simplify. I suppose I have my answer, x1 is equal to x2. And if I get the result x1 equals to x2, I should be able to come up with the conclusion to say that f is a one-to-one function shown. And if let's say they want to have further explanation, why is this one-to-one? Then this is the reasoning that you should have, the reason. This is the reason. Where we have, sorry, missing the f here. So fx1 equals to fx2. If this implies that x1 equals to x2, where start from this, we get the answer fx1 we get the answer x1 equals to x2. Therefore, f is a one-to-one function. Continue. C, we would like to find the inverse. So again, inverse, I don't want you to do the let y method, but instead I want you to use the properties of by the time you have f composite f inverse, you got the answer of equal to x, and this x is depends on what we have inside the bracket. If it's a x, then x. If it's a y, then y. Then what is the meaning of this calculation here is that we substitute function inverse into function f for whichever position you have x. So as a result, I have 5 power of 3 minus f inverse plus 4. This term here may not be looking very clear in the typing. It's actually 5 to the power of 3 minus f inverse plus 4. Then it is equals to x. Rearrange the terms so that I have the inverse on one side, the rest on the other. So this is the result I have. I minus 4 on both sides. Then from here to the next line, be aware what I happen to do is that I doesn't have this step here written very clear maybe. So how do I get the following result here is because, watch out, I insert log base 5 on both sides, where I have 5 to the power of 3 minus f inverse and x minus 4. So as a result, this part here by properties, I'm left with the power only. The other side maintained like this form here. Further rearranged, I have negative f inverse is minus 3 plus log x minus 4. But I don't want negative f inverse, I want f inverse. So the whole thing I multiply with negative 1. So that goes the answer for the inverse. And in here, if you ask, can I just use natural log ln to solve the questions? Yeah, you may use the natural ln to get the answer, but the answer may not look very simplified after this. Then I want to state the domain and range for inverse. So in here, whenever dealing with inverse, instead of you trying to direct look from the inverse to get answer, you can always make use of the properties. The inverse for functions, sorry, the domain of inverse is always same as the range of f. The range of inverse is always same as domain of f, and therefore this is the answer that we have. This is actually equal to the range of f equals to the domain of f. Have a quick check on part A. Then last part E. I make a typing error here. By right is using the result in C. Then how to solve the question. So what is the result from C is that the result from C is that we have the inverse. We have the inverse. How does this inverse here, it will help us to solve the questions. Let's see. How does this inverse here will help us to solve the questions of finding G? The question has specific requirements to get the answer, so you must make sure you fulfill the specific requirement to get the answer, not just simply use your own methods to do composite function, whatever, to get the answer. So how shall we get the answer here is that, watch out, I would like to consider my answer in the way that I would like to interpret this composite into the way of F composite G is actually equivalent to F composite G written in this form here, where substitute function G into function F, where this one is given in the question, the other one we find by ourselves. We do calculation by ourselves, and then from there we get the answer. So with this idea as a start, sorry, I think this is the expansion for the composite. It doesn't help to solve G. So what is the thing that actually I want to use here is that I want to make use of the inverse. So after you understand about this idea here is that, what if, let's say, I have considered both of them, substitute into the inverse function, which I have the case of composite like this. Wait, how should I write it? Let me erase this part here first. I need to make use of the inverse. Okay, maybe we can think back in the idea just now about the inverse properties. When the time I have inverse composite with f, whatever inside the brackets here, it will be the result that we want. So this one, if let's say hashtag, so I will have the result as hashtag. And today I don't want to use the terms hashtag. I want to have the hashtag to become gx, so that it will bring me to the answer for gx. So we find out that this is the clue to solve the questions. This is the clue to solve the question, and I realized that these composite functions here is actually we have the inverse composite f, composite g, have a triple layer. And this triple layer here is also able to define in the way of f inverse with substitute fg inside. And these two are equivalent to each other. And now we want to make use of these two equivalent to each other to solve the questions. And therefore, I may start my solution in the way that go on. Hey, wait. Wait. It seems that not necessary to consider so much. Oh, okay, sorry. Let's see the solution. Actually, it's quite short with all my explanation that for something that is not necessary to consider in the calculations here. Okay, so maybe I just need to have the idea on here will be good enough. And then this part here, I'm going to replace with another form, this one, for further calculations. So, by the way, what I happen to find out is that, again, using this idea here, so let me slowly to explain back to this result here, how can I start with from here, is that we find out that if let's say I have G inverse composite F, composite GX, it is actually equals to GX. And I want to find Gx, right? By right, rearrange the equations. I have Gx equals to F composite F Gx. And this term here actually, according to the idea just now, this is equivalent to composite 3-layer like this. And this is also can be able to write in this form here. So this whole thing here, I'm going to turn it to become G inverse bracket F composite G, where I'm going to substitute F composite G into the inverse function to solve the questions. And as a result, the inverse function in this one, all the position come with X, I substitute with Fg. And the Fg is actually X plus 5 according to question. So I further plug inside. Simplify the answer. That is the answer for my function G. Itu saja. If you just refer to this solution here, it's as if like whenever the composite, it happens that I have inverse and F contact each other, as if like it can cancel off. So I have the remaining one as the result of the function Gx. Then the calculation as follows to get answer. Using the properties of inverse, using the idea of composite. Go on. Next. Question number 5 in section B. Regards on the case of limits, and this question is quite tough. So let's just have a quick look. You was told that you have a function fx given by square root of x squared plus 4 divided by x minus 2, where x is not equals to 1. Where x is not equals to 1. And then we want to go on for the further calculations here. And let's see how shall we get the answer. And then I think I want to hold on. Maybe there is a corrections on this question here, where x is not equal to 1 is not a proper things happens to this question here. I suppose this is supposed to be x is not equals to 2. So that will be more valid. Please make a correction on these questions here. before we start to solve the questions. Is this not supposed to be not equals to 1? By right, it's supposed to be x is not equals to 2. Then only this thing is valid for our further calculations. Okay, now if x is not equals to 1 with this function here, x is not equals to 2 in this function here. Now let us calculate the functions for limit x approach to 2 minus and x approach to 2 plus. And how should we get our answer here done? Okay, let's see. This is a one-sided limit. If we try to do calculation by direct substitution, substitute 2 inside, what happened is that we'll see that we have the result of substitute 2 inside. I have the answer of square root of 8 over 0. Constant over 0, I suppose that I have the case of plus minus infinity. But whether it's plus or minus, I have no idea at this moment. So I need to go for further calculations. The same thing will happen for the right-hand side limit. Then next, x approach to negative infinity, x approach to positive infinity. If I do direct substitution, I believe I have the situation that I have the case of infinity or infinity. Whether it's the case of plus minus depends in our calculation later. Then in this type of situation, how shall we solve? We'll see later. Next, they ask to state all the vertical and horizontal asymptote. So in this question here, you are mixing the horizontal and vertical asymptote in the same part of the question. So make sure you write down the words clearly, who is vertical and who is horizontal asymptote. And the question use the word state, that means that you can write down direct answer. There's no more calculation at this moment here. We can just observe and write down the answer. And I suppose the answer I should be able to observe either directly from the questions or maybe the solution for part A and part B. And at last, with the informations given about the intercept, and I suppose this is the y-intercept, missing words there. And also this information, what does it mean? And then they ask us to sketch graph. So maybe it will be helpful later when the time we try to sketch graph, we will see later. Now we start with part A first. Again, make a corrections here. I suppose the corrections I need to make here is that it should be not equals to 2. So what we do now is that we try to do the calculation. Limit x approach to 2 minus for fx. Substitute the functions. So just now we find out the answer is constant over 0. So this result should be plus minus infinity if we substitute 2. And to know plus or minus, we do a test value. We substitute with a test value. So 2 minus, let's say I choose a test value of 1.99. I substitute inside. And I suppose I get the result coming out as a negative value. So therefore, it tells us that it's negative infinity. Similarly, for the case of 2 plus, substitute the function. Direct substitutions, it will give us plus minus infinity because constant over 0. Whether it's plus or minus, 2 plus, choose a test value, 2.01 for example. Substitute inside, check the result is positive. So I have positive infinity. So this is the result for part A. Part B, again, there's a corrections, not equals to 2. And now I want to find the limit x approach to negative infinity and limit x approach to positive infinity. And what is the answer that we should have here? We start with the case of limit approach to negative infinity as required in the question. Substitute the functions and watch out. If you do direct substitutions of infinity inside, you got the result as infinity over infinity. Positive infinity on top, negative infinity below. So in this case, I need to divide with the highest power of denominator in the way of top and bottom. And in here, highest power denominator is x. So I suppose to divide x on top and x below. Okay, continue. Watch out. However, you find out that for the denominator, I can divide it easily to become 1 minus 2 over x. However, the top part here, I still hang in there with the square root. It's not yet simplified. So I need to do some modification on the x on top here so that I can divide the square root as well. So let's see the relationship between the x and also square root of x squared. Again, we're back to the definition of modulus. Modulus x is positive x when the time x is greater than 0. Negative x when x is less than 0. First definition is like this. Second definition is square root of x squared. With the combinations of the two definitions for the part that I highlighted in yellow, so what I can see is that for the part highlighted in yellow, I will have square root of x squared equals to x is for the case of x is greater than 0. Or maybe we can write x equal to square root of x squared, whichever comes first. Whereas for the bottom one, which I highlighted in blue, it gives us the package that for the case of x is less than 0, you can either have square root of x squared equals to negative x or x equals to negative square root of x squared. Now, we would like to replace this x here. We would like to replace this x here we would like to replace the x here, as I highlighted, into the form of square root of x squared. But whether it's a plus or minus case, how you decide? You check your x. X approaches to negative infinity. So therefore, this is the situation happens. Less than 0. So I find out that the x, I shall replace it with negative square root of x squared. And with these divisions here, you find out you will divide with negative square root of x squared like this. So the top part will give us result square root with minus outside 1 plus 4 over x squared. And therefore this is the result of the divisions happen. At this moment here, by right you can proceed further with direct substitutions on these two parts I highlighted in purple and get the result equals to 0 and answer is negative 1. Continue. Similar things that we're going to do for the next one, approach to positive infinity. So, but positive infinity, it won't be as complicated as just now to consider so much thing, but yet still based on the same definitions lah. So when the time you do divisions here, again similar like just now, we divide with x over x, but we find out that the x on top is not so suitable to divide with the square root of x squared on top. So we need to find a replacement with the condition that x is approach to positive infinity, which is x is greater than 0. So the x can always replace with positive of square root of x squared. And as a result of the division, similar like just now, it's just that I don't have negative sign anymore in front. And then we simplify our answer. We have the result as follow. Go on. After I have both of this answer here done, we go for part C again. So part C, again, correction on this. They ask to state all the vertical and horizontal asymptote. We start with vertical asymptote. Vertical asymptote is happen when the time, if let's say limit of a certain value, whether it's for the left hand limit or whether from the right hand limit or the left hand limit, this answer here give us either plus or minus infinity. Either one of them get plus or minus infinity. Then we say x equals to a is vertical asymptote. And in these questions here, you find out that the a value is some value that is undefined in the function. And in this question, the undefined value is 2. And I realize that limit from the left of 2, I get negative infinity. By right, just this one here is good enough to tell that vertical asymptote is actually x equals to 2. Sekadar ini saja sebenarnya sudah cukup. Atau sekadar yang bawah punya 2 plus sudah cukup. But the question asks us to find both, that's why we find both lah. But by right, either one of them will do. And based on the result from A, I can tell that the vertical asymptote is x equals to 2. And you make sure you write down the word vertical asymptote. Don't let us guess that whether the x or the y is the case of vertical asymptote. Then the horizontal asymptote, how we get the answer is that refer on part B. When the time you have limit approach to negative infinity, what is the corresponding value found out? Combined with y. So y equals to -1 is the horizontal asymptote. The other one, y equals to 1 will be the horizontal asymptote. So in this case here, we have two horizontal asymptote, which is y equals to plus minus 1 lah. So that goes the result. You may write in this form here. You may write in the form of like list out. You may write in the form that have each one of them have y. It's all right. Just make sure the y is there lah. Continue. Now we finally want to go for graph sketching. Okay, again, this is not equals to 2. So how we do the graph sketching here is that, guys and girls, I need to make use of the info of the vertical horizontal asymptote and also the previous part of the calculations of the limits. Okay, so therefore, let me have a rough sketching on top here, and let me erase the unnecessary trace that I have drawn previously. Then we try to consider on how to do the graph sketching. Okay, first I would like to start with the horizontal axis, which is the x-axis. And then I will continue with the vertical asymptote, which happens to be negative, sorry, not negative 2, x equals to 2. So let's say I consider reserve here as 0. So here is x equals to 2. So it should be at asymptote. Then my y-axis may be somewhere here. And then the horizontal asymptote, as we find out that I have a horizontal asymptote located at plus minus 1. So this is y equals to positive 1. Y equals to minus 1. And then watch out, we try to do our rough sketching for the graph now. Based on the info for the part A, approach to 2 minus is going to negative infinity. That means slightly on the left of 2 minus, the graph is approaching to negative infinity. That means I have something like this, like the tail. 2 plus, it will go all the way up to positive infinity. So the tail will go something like this. Later, the curve will turn into which form? At this moment, I have no idea yet. But this is the framework that I have for the info from A. Then from part B, what I find out is that when x approach to negative infinity, I will have the answer is actually getting y equals to minus 1. That means when the time the graph approach to negative infinity, we find out that the graph is getting very close to y equals to minus 1. So in here, when the time approach to the negative infinity means towards the left, our graph is getting very close to y equals to minus 1, but it can getting very close like here on top or below of the asymptote y equals to 1. And which one is the appropriate tail that we have here is that, let us try to see the extra information from the graph sketcher. Maybe it will give us some idea. The question tells that we have a y-intercept at 0 minus 1. So that means in your graph later, 0 minus 1. That means the graph akan sentuh asymptote ini ya. dia akan sentuh pada point ini. Check balik, betul ke? Kosong minus 1, yes. Then later what you was told is that in the third quadrant, we have the fx value here, which is the y value, is between 0 and also 1. Where is 0 and also 1? 0 and also 1, that means I will have somewhere here lah. Tapi saya rasa ada typing error lah, because 1 is greater than 0 kan. I suppose this question here ada kesilapan juga, tak logik. Tolong buat pembetulan balik, nanti saya akan pembetulan balik juga dalam soalan. So, I suppose there is a typing error there. I'm not sure the printing copy ada salah ke tidak, tapi the display here salah. Ada missing. Here is y-intercept, and this supposed to be minus 1. The y value is between minus 1 to 0. That means in the third quadrant, your graph bukan dekat bahagian sini. In the third quadrant, first, second, third quadrant, your graph dekat bahagian sini. Maka, what you find out from the second info here is that kalau sini adalah the y-intercept and then the graph ada pada bahagian sini, maka for this part, the tail, it won't be the bottom one. Mesti yang ini. Because this is in the third quadrant. The third quadrant mesti dalam lingkungan negative 1 sampai 0. Then go on, approach the positive infinity. What we happens to find out is that positive infinity, we find out that our y value is 1. That means at positive infinity is getting very close to 1. So maybe lah dia macam ini di atas atau macam ini di bawah. So which one is more appropriate? Maybe lah we can try to have a quick check. Is it possible that I have the case of square root of x squared plus 4 over x minus 2? The result is equals to 1. Adakah saya boleh dapat hasil daripada sini kalau saya cuba buat kiraan? And maybe you can try to make use of a calculator to solve the answer. Is it possible to have this to be solved? And then you can decide lah whether the graph akan di atas ke di bawah. Kenapa? Sebab kalau this one happen to be can't solve, that means the graph will connect macam ini saja. This is the case of can't solve. Kalau there is some x value can be solved, then you akan nampak ini bukan graph dia akan connect in the other way around lah. Dia akan cross dia. Dia akan go across the y equals to 1 and then balik kepada asymptote. And also you need to further consider adakah dia akan potong x-intercept ke tidak. So there is a few things I need to consider. But first, when the time I consider this, if I find out can't solve, therefore I don't have to consider the x-intercept part. So by right, the graph will teruslah macam ini saja. And then combine all the info that we have so far to do the sketching. Therefore, this is the rough shape of the graph that I have. And by the time you draw the diagram, it will look something like this. Di mana ini graph yang lebih proper, lebih cantik. And you can see lah, y-intercept. The graph is between minus 1 and also 0 for fx. This is the case that between minus 1 and also 0 for fx. Okay, so that is how we get the answer. Again, there's a corrections there on the questions. Apakah correction dia ialah ni sepatutnya ada satu y-intercept, sini sepatutnya lah negative 1 lah. For the question D. Okay, go on. So after we have solved for question D, now we go for question number 6 in section B. Regards on differentiations. So let's see what we have for question A. You are given y equals to x ln x, find dy dx. In terms of x and y, your final answer can have y inside for the dy dx. Then you have the case of parametric equations, x, y given. They ask you to show dy dx as follow, second derivative as follow, and then calculate the second derivative when the time the t is pi over 8. And let us tackle one by one. Start from question A first. So question A, what I have is that I have x to the power of ln x. To get this answer here done, it's a good idea that we try to make use of logarithmic differentiation, where we don't want the x power like this. So we insert natural log on both sides. And as a result, what I have is that by the properties, the power I can bring to the front. So it becomes ln x multiplied with ln x, which I have ln x squared. The square is for the whole log. Please make sure the square is for the whole log. And then from here, we proceed further to do our differentiation. By implicit differentiation, this one, when the time you differentiate, you have the result as 1 over y dy dx. For the other one, I need to make use of power rules. By power rules, recall. So I have the answer n multiply hashtag power of n minus 1 multiply with the differentiation of the hashtag. So as a result, I have 2 times ln x, and the whole thing I multiply differentiation of ln x 1 over x. So simplify 2 ln x over x. Then I have my dy dx equals to get rid of this 1 over y, multiply y on both sides. That goes the result. 2y ln x over x. That goes the result. So this is the answer we have, right, in terms of x and also y. Proceed further. B, for these parametric equations here, again, I want to recall on the idea. What is sine square t here is actually sine t square. And you need to use power rules to solve the questions. So the question asks you to find dy dx and show that the dy dx getting this answer. So in order to find dy dx, first let us try to consider differentiate the x and also differentiate the y with respect to t. So when the time I differentiate x with respect to t, what I have for my answer is negative 2 sine t. And how I get this answer, recall back on the concept. Differentiate with respect to t. In here t, for the case of cos, let's say hashtag. Switch the trigger ratios, I will have it that cos switch to become negative sine, multiply differentiation of the angle. The angle is 2t, you differentiate it, you got 2. And 2 multiply with the negative sign, that's why you have negative 2 sine 2t. Differentiate the y with respect to t. 2t, you differentiate, you got 2. By power rules, you differentiate, you got 2 sine t cos t. And reach up to here, if you realize the angle here is t. The final answer is 2t. So we try to find, is there any way that we can convert the t into 2t? And in here, you find out that the conversions is possible to be done. Recall back on the idea of the double angle formula for sine. Sine, let's say I have sine 2 hashtag is equals to 2 sine hashtag cos hashtag. So this one, reverse process. 2 plus sine 2t. Once we get this done here, proceed with our calculations. How to find dy dx? It will be dy dt multiply dt dx, where this one is 1 over dx dt. So substitute dy dt 1 over dx dt 2 multiply with 1 over minus 2 sine 2t. I will find out that I have the result. Let me write some extra line before we go for the final answer. My original final answer may be short. So in here, I will have the division happen to be negative 1 over sine 2t divide, I have negative 1 over 2. So as a result, I have negative So 1 over sine is actually cosecant 2t minus 1 over 2. And is this the answer that we want according to the question? Yes. So we have done the proving shown. Then go on, we go for the second derivative, the calculation of second derivative, and then we get the answer. Second derivative also shown. If let's say you fail to show, you can do the hands part, substitute the pi over inside for further calculation. So anyway, let us try to see how to get this answer here. If we find out that the dy dx is equals to negative cosecant 2t minus 1 over 2, and by the time I want to find the second derivative, the formula will happens in the way that I will have the second derivative is equals to, I would like to have differentiate with respect to t on the dy dx multiply with dt dx. So as a result, what I have for my answer here is that differentiate the dy dx with respect to t first. And in here, what we find out is that we want to differentiate this dy dx with respect to t. So the constant will be disappear. We focus on the differentiations on the cosecant. So the idea is that you change the trigo and then multiply with the differentiations of the angle. Cosecant, when the time you change it, it will happens to be you do the differentiations on cosecant. I suppose that you have the answer as cosecant, cotangent, come with negative. Okay, recall balik lah. Let me write down step by step for the answer here. When the time you differentiate with respect to t, for negative cosecant 2t. So by right, it will happen in the way that the negative sign maintain dulu. Differentiate cosecant, I will have it as a negative cosecant 2t multiply with cotangent 2t, and then differentiate the angle, multiply 2. Negative, negative, simplify, become positive, multiply the 2 in front. This is the result. Then don't forget, multiply 1 over dt, dx dt. So there goes the result. And reach up to here, we don't want to leave in this form here for final answer. We want to leave in the form of cos and sine as required by the question. So the cosecant and cotangent, let us convert into sine in terms of sine and cos. So this is what I have for the cosecant and also cotangent. Then the terms behind here, dt dx, don't forget. Now you should be able to see constant 2 and negative 2 can be simplified. So it turn become minus 1. Multiply with cos. So I have it as negative cos 2t. Sine 2t, sine 2t, sine 2t, multiply 3 times, power 3. So we have done the proving shown. There goes the answer. Then finally, nothing much. Evaluate, just substitute the pi over 8 inside for further calculations. So when t equals to pi over 8, we substitute, we find out that we have negative cos pi over 4. 2 times of pi over 8 is pi over 4. Pi over 4. Press calculator, the answer is negative 2. And once again, the calculation here is being done in the way of sine pi over 4, power of 3 in your calculator. Lastly, refer to the last question in section B, question number 7, regards on the case of rate of change in chapter 10, application of differentiation. So what we have in these questions here is that the questions tell that there's a figures below illustrate that a girl with a height of 1.5 meter is walking at the rate of 0.7 meter per second towards the lamppost. So it is walking towards in the rate of 0.7 m per second. And you will told that the lamppost with a height of 5 meter. This is the situation that happening. And in the diagram, you can see that there is a shadow there. And this is the tips of the shadow. And the tips of the shadow is actually formed from the light from the lamppost. And now what we want to do further is that let us consider the following situations. If let's say the length of the shadow, this is the shadow, the length of the shadow is happen to be x. The distance between the girl and the lamppost is happen to be y. Then what is z pull up? Z is actually the distance between the tips of the shadow and also the lamppost is z. That means this is the xyz. They ask us to express x and z in terms of y, and then follow. We want to determine the rate in at what rate where the shadow length is changing. So the shadow length is actually referred to x. So in here, the rate of the shadow change of shadow length is dx dt. Find out what is dx dt. Then how fast is the tips of her shadow moving towards the lamppost? So if the tips is moving towards the lamppost, that means it will happen to be comparing the tips and also the lamppost. That means we're considering the rate of change of the z. So this is what happened along what we understand from the question and the information before we try to think of the strategy to solve. A, find x and z in terms of y. That means I have z equal to some function y, x equals to some function y, z equals to some function y. Then find out what is dx dt and also dz dt accordingly. And then let us try to start with the first one, express x and z in terms of y. And from the interpretation from the diagram on top, let us have the diagram written in this form here, draw in this form here. So we find out that based on the summary of the diagram just now, actually I can form two right angle triangle, the smaller one and the larger one. Where this pi here is the constant value, 5 always maintain as 5 because this is the height of the lamppost. The lamppost doesn't grow up. It doesn't grow up, so it's always stick with 5 meter. 1.5 is the height of the little girl. The girl doesn't have any changes on the height along the walking, so also maintain as 1.5. Then the x, y, and also z, which is the distance that we have discussed correspondingly just now. Now, make use of this triangle here. We shall able to find out what is the answer if I want to have the x written in terms of y and the z written in terms of y, and how we get this answer here. So guys and girls, in this case here, although you see right angle triangle, but we cannot make use of Pythagoras theorem to get the answer. But instead, we're using similar triangle to get our answer. Where we have two similar triangle, which is the larger one, 5, and then we have x plus y for the distance. I don't want to relate with z first because I want to find x in terms of y, so I just write in terms of x and y. So the distance between is x and y. This is the larger triangle. The other smaller triangle which happens in the way this part here is base x 1.5. These are two similar triangle where they have a certain ratio. If let's say I have taken this side here divide with 5, the result should be same as the x divided by 1.5. Or maybe if I have x plus y divided by x, I have it equals to 5 divided by 1.5. So by using the properties that we know on the similar triangle and consider the best way to write x in terms of y, so I have written the equation in this form here where I have x divided by 1.5. So x divided by 1.5, it will same as x plus y divided by 1.5. So x plus y divided by 5. Then from here, I find out that this one, I can split it become x over 5 and also y over 5 as one of the way. But of course, I can also do cross multiply and I get the result as following. so that I get rid of the fractions here. So I multiply 1.5 to the right, multiply 5 on the other side. From here, I rearrange. I find out that I can have 3.5 is equals to 1.5. I write x in terms of y, so I have the x on the left hand side, and finally, x is equals to 3 over 7y. So I get the first answer, x in terms of y. Then z in terms of y, how I get the answer is that, how can I have z related with y? I find out that z is actually equals to x plus y. And if x is happen to be 3 over 7y, so substitute, simplify, I find out that z is equal to 10 over 7y. That's it. X in terms of y, z in terms of y. Then continue. After I have this all info here, the next thing I want to do is that I want to find out what is the rate of change of the shadow length changings, and also how fast the tips of her shadow moving toward the lamppost. How I get this answer here done? Let's see. So first of all, I want to find the rate of change of the shadow length changes. The shadow length is actually refer to the x. And here I want to find what is the dx dt. The dx dt. And this length here, if you realize, when the time the girl moving closer and closer to the lamppost, the length here will happen to be reduced. And I suppose this answer here will be a negative result. And what can I make use of to get the answer for this rate of change here? And overall in the questions here, I only have one rate of change here, which is 0.7 meter per second. And this is actually refer to the rate that the girl is walking, the speed of the girl walking towards the lamppost. When the time the girl walking towards the lamppost, what you happen to find out is that you find out that the distance of y is actually happens to be decreasing in this rate here, and decrease in the way of dy dt equals to negative 0.7. Of course, the shadow also decreasing, but this is the thing I'm looking for. And the only reference I can make use is the rate of change of the y, the distance between the girl and also the lamppost. So now, with the info that I find out that I have dy dt equals to negative 0.7, and I would like to find out what is dx dt. If according to the usual way, what you all do is that to get dx dt, what you will do is that you consider dx dt equals to dy dt multiply with a function that doing with, sorry, you multiply with the derivative where I have dx dy. So that by chain rule, left and right hand side is equivalent, and this one must deal with some formula or some equation with x and y to get the answer. And is it possible to get this one here? And my answer to you is possible, because we have just now x written in terms of y. So maybe from here we differentiate with respect to y. I should able to get this part here done and then substitute for further calculations. And now let us see how to solve the questions. So we find out that in my solution here, I make use of the info. X equals to 3 over 7 y. I do differentiation. If you realize that, if according to the strategy just now, I suppose that I should differentiate with respect to y to get 3 over 7. And then I plug inside here for further calculation. But in my solution here, I try to use another alternative methods where instead of doing chain rule like this, I just directly consider using this equation here. I want to differentiate with respect to t. This is another alternative methods. Again, just now the chain rule idea here is alright, boleh pakai juga. But in my solution here, I'm using another alternative methods where I can just directly differentiate with respect to t. And I got these equations here. And if you realize that this equation here, right, It's actually the same as after you do apply the chain rule. Sama saja benda dia. It's just a different perspective to solve. Then now, make use of the information I know about dy dt just now, which is the rate of change of the distance between the girl and the lamppost in negative 0.7. Watch out, it's negative value. Plug it inside for calculations. I have the answer negative 0.3 meter per second. And this negative 0.3 meter per second, the meaning is actually means that the rate of change of the shadow length is negative 0.3 per second. Go on. Next, I want to find out what is the answer for the next part here. How fast the tips of the shadow how fast is the tips of her shadow moving towards the lamppost? Secepat manalah pergerakan tips itu ke arah the lamppost? And this one I can actually relate with dz dt, where the reductions of the length of z. And how can I get this answer here also? So guys and girls, if I want to get dz dt, according to the strategy just now, if I want to use dy dt, what I do is that I have dz dt equals to dy dt multiplied with dz dy, where in here I need to find a function of z and y. I do differentiation with respect to y to get answer by chain rule. But once again, today in these questions here, I want to use another alternative methods. Instead of using the chain rule like this, based on the info I know z is equals to 10 over 7y, z equals to 10 over 7y, instead of I go to find this differentiation by differentiate with respect to y, I just directly from here, I differentiate with respect to t, so I can have an instant relationship between dz dt and dy dt. And once again, I can substitute easily the dy dt according to info just now. I get dz dt equals to the following, negative 1 meter per second. And this is actually means that the tips of the shadow is moving at the rate of 1 meter per second towards the lamppost. And if you realize, here tak ada negative sign, here tak ada negative sign, because the negative sign is trying to tell the movement saja. And the movement already, it already mentions in the sentence here. So bayangkanlah, this is the shadow, this is the lamppost. Kalau ikut pergerakan ini, moving towards 1 meter per second, this is the movement of these tips here. If we discuss in terms of the movement of the tips towards the lamppost, is 1 meter per second. And if I discuss in terms of the change of distance, so the distance here we're getting shorter and shorter, and therefore it's being described by negative 1 meter per second. So please be alert lah when the time you consider the negative sign in interpretation and also in calculations. Okay, so I guess that is all lah for the discussion on this set of paper here. And I'm sorry for any of the last minute corrections that I find out in the discussions here. So I will adjust it back and then post the answer in the Google site. If let's say there is still a mistake or something that you don't understand inside the answer scheme there, please kindly refer back to me. Thank you very much. And therefore in here, I would like to end the recording here for this discussion here. Thank you very much and bye bye.